Hi everyone, so welcome to 7.2. We're still using the law of sines, but some funny weird stuff happens with the law of sines where it makes this weird case that you can have more than one triangle if they give you certain things. Okay, so let's take a look at our different cases with that and kind of understand why it happens. So if we're given angle side or side angle, I wrote it as SSA. Remember in geometry, you guys thought it was hilarious, ASS. So if we're given angle side, three different things could happen. Okay, one, that side, because you're given angle side, so you'd be given angle B, side A, and side B. Okay, so these are the things you'd be given. So what might happen is, given that angle on that side, this side is not long enough to make a triangle. So that means that no triangles would exist if those were the numbers that you were trying to use, right? Or if you were given angle side, everything might be fine. You might just have a regular one triangle thing and you would do it just like we did last class, okay? And then the last case, if you were given angle side, is that side might be able to form two triangles, okay? And that would be because it can swing and move over here. So you would have the big main triangle here that you see, but you would also have that little triangle if we moved it over there. So this happens because of sine being defined where it is. Since you have a positive value for sine in quadrants 1 and 2, you can have the same answer and those angles would still be enough to add to be a triangle. So if you look down at the bottom, it kind of makes a little bit more sense if you think about it this way. So because the supplementary angles can have the same sine value, we can end up with having those triangles where it exists in both triangles. So like the sine of 60 and the sine of 180 minus 60 are the supplementary of it. They're both root 3 over 2 because it can happen in quadrant 1 and quadrant 2. So that might mean that given whatever special numbers that they gave you for A and B and the angle, there might be an angle that's obtuse or acute that gives you the same numbers, like 60 or 120. So you end up forming two triangles. So I have a picture that looks horrible, but this is like the main thing, like the one up there. So you have that one skinny triangle and then the whole triangle, which I don't know what happened to the other part of it. So you end up with two, which means you'd have to solve two triangles for that one problem. Okay, so I have the steps listed for what we would do in case we have an ambiguous case. So we could have 0, 1, or 2 triangles. Okay, so we're going to go through these steps and try to figure out what's going on and how they would happen. So let's take a look at our first example on the inside. So for this one, or for all of these ones that can be ambiguous, I always draw my picture where, before I start, where it looks like this. Because I don't want to connect it and assume that it makes a triangle if it might not. So when I sketch my original picture, I draw it not closed. And then once we find out that it does make a triangle, then you can close it. So they gave us angle B, which is 55.6. They told us side B, it's 8.94. Remember, sides across from the angle. And then they gave us side A. So based on the way I drew the triangle, A would go here because it's angle side. If you put A at the top, then that would just mean that this is the side that doesn't connect. Okay, but I always draw it like this and put the two sides that they give us up at the top. So this is what they gave us. So now we need to test and see, does this actually make a triangle? So we're going to plug into the law of sines with what we have and see where to go. So for this, we'd be finding an angle. So I don't know if you noticed last class, all the ones we were finding sides, not angles with the law of sines. The ambiguous cases happens when you're finding angles for the law of sines. Okay, so we would have the sine of angle A over its side equals the sine of 55.6 over 8.94. Okay, so when you're solving this, you'd times by 25.1, just like how we times with a sign for the other lesson, but now you'd have to get rid of the sign here. Okay, so let me write out those steps because I usually don't write them all. So we'd have the sign of A equals, now we times by that, so it'd be on the other side, sign of 55.6 over 8.94. And then we need to get rid of the signs. So to get rid of signs, we have to take the sign inverse of both sides. Those would cancel. So angle A equals the sine inverse of 25.1 sine of 55.6 over 8.94. So we would test that out, or we type it in our calculator to see what we get. So I'm going to do the fraction part first, and then we'll do the sine inverse of that. So 25.1 sine of 55.6 divided by 8.94, and we get 2.3165. So if you remember what our domain, or the range is for sine, can we take the sine of that? We cannot. So if this is greater than 1, then that's when no triangle exists. Because if I try to take the sine inverse of that answer we got, it says math error, because you can't do sine of something greater than 1. So that means that we have no triangle. So I'm just going to write it a little bit so you remember. So when we divided all that, we ended up with 2.31, I think it was. And that number is greater than 1, so no triangle. So those are going to be your favorite kind, because then you don't have to do anything else. So this was like this one, where no triangle is going to exist. Okay, so let's try another one, see what we got. Okay, so I'm going to go to the right. So we're going to draw our little incomplete triangle. So this time they gave us angle A. Whatever angle they give you, I always put it in the bottom left corner. I'd like you guys to do that too, so all of our pictures are the same. And then they gave us the side across from that is 10.7. And then this is going to go in between them. So that means C is down here, 7.2. So what would be up there? Okay, so we're going to have to do the same steps we did on the other one to see if a triangle exists. And if it does, we have to check to see if two triangles are there. So we have the sine of C equal or over 7.2 equals the sine of 43.5 over 10.7. So the sine of C is 7.2 times the sine of 43.5 over 10.7. So let's type it in our calculator to see if we got anything. So 7.2 times the sine of 43.5 divided by 10.7. So we do got something because our number ended up being less than 1. So now remember, we take the sine inverse of that answer. So that tells us what angle C is. So angle C equals 27.5933. Okay, so now we have to check to see if there's two triangles. So the way you do that is, remember, it's because this could be just our reference angle, and we can come up with the same side lengths in quadrant 2. So we have to see if the supplement of this is going to be small enough where it'll still make a triangle with this 43. So when we check for 2, we would find the supplement of C first. So 180 minus our C. I'm just going to round to 2 decimal. It's too much to write. So when we subtract those, we get 152.41 degrees. So if another triangle exists, that's what the other version of C is. I call it C2, and this is C1. But we have to see, does this other version of value for our angle, is it small enough to add this to make it equal 180? Because remember, the three angles in the triangle equal 180. And if it equals more, then we wouldn't have any space for our third angle. So 152.41 plus 43.5. So add 43.5, which was your original. So this is angle C2. And this is our original angle A. And if that's more than 180, we don't have two triangles. So it ended up being 195.91. So that means we can't have this in our triangle because it's going to be bigger. So there's no two triangles. It's only one. Only one triangle, which is your lucky day. So we have angle C now. We can make our need list. So we need, oh, and you can also complete your triangle because you now know it actually works. So we need angle C. We would need angle B and side B. So we found angle C, 27.59. We can find angle B easy now because we can subtract from 180. So 180 minus 27.59 minus 43.5 gives us angle B to be 108.91. So now we just have to solve and find C, or side B, sorry. So we would set that up just like we did with all of our stuff last class. So B over the sine of B equals, and the ones we were given was A, so we're going to use those. So 10.7 over the sine of 43.5. So if we cross multiply and times everything out, we get that B equals 14.71. And that's it. So we solved our triangle. One thing to maybe help you make sure your answers make sense in the context of the problem, remember that the biggest side is always across the biggest angle. So our biggest angle here is B. So that means your biggest side has to be B as well. So if we would have got like a really small number for this, we would have known we messed up somewhere. And it would have to be bigger than those other ones. Okay, so let's try the next one. So when we start, we're going to draw our incomplete triangle, fill in everything they gave us. Okay, I do want to give you one. If this side across from the angle is bigger than the other one, it's always only exactly one. It's when this side's bigger that it could be 0 or 2. So that just might, help you out so you wouldn't have to bother checking. So if that side across from the angle is bigger than the other one, you got one triangle. This one's not bigger, so that means we could have 0 triangles or 2 triangles. So we need to set up to find angle B and test it and see if it actually makes just one triangle or more. So sine of B over 24.9 equals the sine of the ones that they gave us, angle A, over side A. Okay, so the sine of B would be 24.9 times the sine of 55.3 over 22.8. So try to see if we can find angle B. So if we do that fraction part, 24.9 times the sine of 55.3 divided by 22.8, we get a number that's less than 1. So that means we can take the sine inverse of that to find an angle. So angle B equals 63.88 degrees. So definitely have one triangle. Now we need to check to see if we have 2. So when we check for 2, we do 180 minus angle B, because that would be its supplement. So we got 116.12 when we subtract those. So that would be our angle C2, or B2. JK, we're finding angle B. That would be B2, the other version of B, if we can make a triangle with this. So now you have to add back in that angle A, so the 55.3. And if we add those together, we get 171.42. So since that's less than 180, that means we have 2 triangles. Okay, so we would make a list for triangle 1 and make a list for triangle 2. So in both triangles, the things that they give you do not change. Okay, so triangle 1, so we have angle B1, angle C1, and then side C1. In triangle 2, we're needing the same thing, but we're going to label them B2, C2, and side C2. So we know some of these things because we already found them. We know angle B1 is 63.88. Angle B2 is the one that we found down here, the supplement angle to that. So 116.12, I think I read. I can't read it. So then we can find those C angles because they're 3 angles add to be 180. So 180 minus B and minus A will give you C, and then 180 minus this B and A gives you your C2. So if we subtract, we get 60.82 degrees, and then C2 is 8.58 degrees. So we just found those because the 3 angles add to be 180. So now to find your 2 different C's, you're going to have to write an equation for C. So remember that C over the sine of C equals, and we were given our A's, so we'll use our A's, so 22.8 over the sine of 55.3. So you would plug in your 2 different versions of C to solve for C. So if I multiply, I'm just setting it up like this so we can see that where we plug things in, and then you don't have to do it twice. So for the first triangle, we're going to use this C. So our fraction would be 22.8 times the sine of our first C, 60.82. And then in the bottom we have sine of 55.3. So that means that C1 is 24.21. Now for C2, we plug this angle in for C. So since I have all this stuff typed in, I'm just going to go back up, delete the angle C I put in before, put my new angle C, and find my new side C. So 4.14. So 2 triangles isn't that bad. You really are just finding one more thing because the angles are just supplementary. And that's it. Okay. So the video is getting kind of long, so I want you to pause, try this example, check for 2 triangles, and then solve whatever you got. And then when you come back, I'll show you the answers. Okay, so luckily in this one we only had one triangle. So we ended up with angle A was 45.97. We subtracted that from 180, so that would be your angle C2 if it exists. But when we add the original back, we get bigger than 180, so 2 triangles don't exist. So then we can use this to find side C. You subtract from 180 to find angle C. And that is all. Okay, so make sure you write down any questions you have. I know this lesson can kind of be one of the harder ones, so we got to make sure we get our practice done in class. Werner out.